taking your last class about sensor and transducer, and after that the course will be closed, means course will be finished. Okay, so I just started in. I have already discussed lot of ideas and the examples, applications, okay, and the operations of sensor and transducer. Also discussed about the basic differences of sensor and transducers, different examples. Okay, so only few slides are pending. So in this class, I can complete slides. Okay, and I can close my I can close my syllabus. Okay, for this semester on electrical measurement and instrumentations. So in my last class, I just started with giving some of the brief idea on Hall effect sensors. Okay, so that portion I have started. That portion I told you. So due to the changing of the magnetic fields, okay, so due to the changing of the magnetic field, that may cause some electrical voltage developments, okay, and you can apply and you can measure that voltage, okay, and you can measure that voltage to find out the equivalent parameter, okay, and find out the equivalent parameter that you are want to measure. Okay, so last one is your Hall effect sensor that I told that in my last class. Professor Hall that told you that Edwin Hall. Okay, so first invent this transducer. That's why the name of that transducer is called that Hall effect sensor. Okay, Hall transducer. Normally, we are developing here to provide the non-contact mean to detect and measure the magnetic field. Okay, so change of the magnetic field, you are going to done this, going to do this measurement. Okay, so it's a non-contact. Okay, so that means from the outer side means you can able to measure it. Okay, how they work. Okay, first you need to know that how they are working. So presence of the magnetic field. Okay, they are deflecting the electrons flowing through the conductive materials. Okay, so here you can see the descriptions of the principle of the Hall. So north and south, both of the poles are there, and you can see the lines of force are coming from north pole to south pole, and in between the north pole to south pole some plates are there, and that is responsible for flowing of that Carter flux is there, na? So conductor is there, plate is there, that is flowing for induced EMAT, that you are going to be measured. Okay. So as the electron move one into conductive material, okay, so it's a conductive material, okay. The present, the potential is developed in direction perpendicular to the gross current flow, okay. So the potential indicates the strength of the magnetic field, okay. So you can understand that effects of the potentials, okay, why it is important and how they are implementing, how they are working, okay, and as getting your potential, you are going to, and you are able to measure that value, okay. Then applications, in my lesson I told about you some of the applications of Hall effect sensors. So normally you are using that IC engines, okay, IC engines, electronic ignition systems. So specifically they have internal combustion engine, okay, so that electronic ignition system using that sensor for determining the position of the crankshaft, okay, position of the crankshaft, okay. So in IC engine, you know that shaft is always there, the shaft movement, okay, is decided by your chemical energy, means combustions, okay, so that is responsible for movement of the shaft. So who will determine that movement of the shaft means as a rotating portion. So if there is some magnetic part, magnetic field is there, permanent magnet is there, and the rotation is observed inside of that magnetic field, so you can say like that due to the changing of that magnetic field, okay, so that shaft movement can be counted, okay, so that equivalent movement will be there. The next one is your brushless DC motor control. Normally I told in my last class that BLDC motor in practical cases is using EV, electric vehicles, okay, so that positions of the permanent magnet rotor, so definitely little important, basically RPM. So all the cases you can see the concept like the tacho generator. Okay, the concept like the tacho generator. So measurement of your RPM. Okay. So that you are getting from where? That measurement of RPM that you are getting from that sensor. Okay, it's Hall effect sensor is well established examples. Okay, for measurement of that sap positions. So otherwise there are other different sensors also be there. Okay, coder decoder. Okay, so different sensor also be there, but it is well renowned one. Okay. So positions of the permanent magnet rotors of PLDC motor. Okay, then assembly lines. Okay, assembly lines where you are using determine the position of the velocity. So you can see that all the cases that rotating portions, you are much more bothered about the rotating portions, that application related to the find out the Polish position, velocity. Okay, like that. Limit the switches, contact led switches. Then current sensing ICs. So electrically isolated alternating the shunt resistor. Okay, so some electrical isolations are required. So if you see in our power electronics applications, okay, so like you know that power electronic applications means intellectual module based drives. Okay, that may be used in your traction system. Okay, so traction system means you know that locomotive. Okay, so in electrical means railway system, traction normally much more famous in our Indian railways. Okay, not like Indian railways and any of the railway systems. Okay, so what happened in control circuit and power circuit? Okay, both of the circuits are different. In power circuit means that converters and that equivalent and that related elements. Okay, that related elements, they are connecting and they are working in the mode of, sorry, they are working in the zone of power applications. Okay, so that control circuit is not isolated with your power circuit, then what will be the problem? In anyhow, anytimes any faults may appear to your power circuit if there is no isolations of your control circuit and power circuit. Basically control circuit is designed with the based on your analog electronics instruments. Okay, so somehow is there any problems is occurred, so direct faults is occurred, that fault directly coming to your power circuit to your control circuit. Okay, the range of the power circuit, you know that in electrical locomotive it is 25 kV in Indian scenario. Okay, if you go for that foreign country, so maybe another different rating may be used over there, but in Indian scenario it is 25 kV. So more or less that amount of 25,000 volt. Okay, that huge amount of voltage will be carrying by that power electronics devices. But in your control circuit of that devices, of the power electronic devices, that maximum voltage is more or less 15 to 25 volts. Okay, so if that voltage, for if any kinds of fault is occurred in your power circuit and that fault is directly coming to your control circuit, then there is a big problem. Okay, then there is a big problem of controller damage. Okay, that's why sometimes that isolations are required. Okay, so who is responsible for that isolation? That type of sensors, or you can say in the manner of transducer, that kinds of transducers are responsible for maintaining that of isolations. Okay, it's a magnetic isolation. So if optical sensors are there, so optical isolation will be there. Okay, so photosensors are there. So all are the example of optical isolations. Okay, so ground isolation means isolations is normally done for that isolating the grounds. Okay, so that's the basic motivations. Okay, so what are the different types of Hall effect sensor? Okay, so different types. So first you can say like the linear Hall effect sensors. Okay, so what are the linear Hall? What do you mean by the linear Hall effect sensors? So from the definition you can see that proportional. So we'll get the output. Okay, output definitely it's an electrical output, and it is proportional to magnetic field strength. Okay, so that output is proportional to your magnetic field strength. Then Hall effect digital switches. Okay, so you can say like that the presence of magnetic field. Okay, the presence of magnetic field above the threshold, okay, above the threshold, turns switched on. Okay, so that you can in some of the applications. Okay, so you have to make that system like that. So above the threshold, that switch will be turned on. But who will take that responsibility? The sensor will take that responsibility. The presence of magnetic field, okay, the presence of magnetic field, the below the threshold turned off, okay. So that threshold values is there, okay. So you can take one example in motor, okay. So in motor, you should not go run the motor below rated voltage, okay. Then what happened? Normally, motors are taking lot of currents, and the rating of the motors, normal cases, okay, is in a kilowatt range, okay. But in special cases are there, like synchronous motor, the power factor is important. But I am not considering of the special the synchronous motor. But normal cases in DC motor, in induction motor, you can say like that. The rating is in kilowatt range. Okay, so that means kilowatt means V into I. Okay, so voltage into ampere, no? So kilowatt range like that. So if any of voltage is reduced, then what happens? That current will be high. You have to maintain that rating, na? So if you want to maintain that rating, so then what happens? Voltage reduced means current is high. So huge current is flowing to the motor conductor. Still there is some different coils configuration is there, like simplex winding, duplex winding, multiplex winding, but still there. But if it is beyond the limiting zone, beyond the limiting capacity of that current flowing through the motor conductor, then what happens? Then motor conductor will be damaged. Okay. That's why, so the controlling switch of that motor turn on turn off. So one thing, it should be maintained. Okay, who will maintain that switches, means when it will be on, when it will be off. If that voltage is below the threshold value, then automatically the current will be high. Okay, so that will be indicated by this transducer. Okay, so at that time you can turn off that motor. Okay, so that's why in motor low voltage protection is there. Okay, so all the electrical components are there. Okay, so in right now you are in only second year, means only third semester. When you are be in fifth semester, maybe seventh semester, so protection is there, one subject is there. So what are the different type of protections we are normally using for our prevent, for saving our electrical devices or electrical appliances. Okay, so a special subject is there. So at that time you can see, so protection is totally based on that measuring instruments, okay, sensor, transducer, but who will detect that value? Okay, so sensor, transducer will detect that value. You can analyze the that value after getting the response from that measuring instrument. Okay, so you can understand that subject, that electrical measurement and instrumentation subject is it's an uses, there are different uses of the subjects, so different subject, different topics of our electrical engineering. Okay, not like only electrical engineering, electronics engineering also. Okay, so I think you are able to understand that below threshold value and above threshold value it should be controlled. Then digital latch, okay, that I'm telling you that digital latches are there. So latches means what? You have a door in your home. Okay, door means door about that room door. Okay, so if you open the door means it is latch. Okay, if you close the door, so you can say like the door open and close, that is a latching. Okay, so north will turn on latch, south will turn on latch. So as per that operation of the door, it will be only pull and push mode condition or push or pull mode conditions. Okay, two of the configurations like that. Okay, so then where we are using the packaging and manufacturing instruments. Okay, so I am telling you now, so a lot of applications of this Hall effect sensor and that photo sensor. These two sensors are in electrical and electronics. Okay, special electronics engineering. Okay, so that's why you can see different diagrams of that devices, means integrated circuits, ICs are there. Okay, so those are providing that isolations. Okay, and applications are there. So normally we are using that analog devices AD22151G from the analog devices. We are using that value. Analog micro systems instruments. Okay, wide range of linear latching and switching sensors. Okay, great sampling policy. So Digital means what I mean, sampling process is there, means how much sampling is there of your switching devices. Okay, more sampling means there is some it is equivalent. Okay, it is equivalent if there is more sampling, so your continuous signal is sampled to the digital signal, more or less taking all those values. But there is some problem. Sampling frequency is high means there is some problems on the stability of your system. Okay, so that's why sampling frequency you can maybe extend to the very high, but there is some limitations. Okay, so more you have to choose those devices having moderate sampling frequency. So normally sampling policy is related to converting, that means policy related to your digital transducers. Okay, so here you can see that transducers are used as a analog as well as some digital. Okay, so that is related to your digital transducers. Okay, many and many more. Okay, so different applications are there. Packaging units means different companies are there. Okay, so they are only working on it, like Honeywell. Okay, so Honeywell. Okay, different companies are there. They are working on it. So here you can see that Hall effect sensor module. So the different diagrams are there. So implementations. Okay, so implementations and words of warning. So warning. So where we are going to be implement that type of sensor. So sensor may be affected on the temperature. You know that things. Okay. So how it will be affected? So definitely affected with the temperatures. Basically, why it is affected with the temperature? Basically, property, magnetic property will change with the temperature. Means you know that magnetic fields are there, no? So that means magnets are there. So the increasing of the temperature may change the magnetic properties of that material. Okay. So there is a problem. That's why it is important. Sensor may be directional. Okay, so it is unidirectional or bidirectional. It is independent with the directional, like your energy meter. Okay, so there is some directional movement. Okay, so that policies you can use for some protection device also. Okay, but that similar thing also happened for the sensor. So is there any rotating device? So is it in the direction is important or not? If it is important, so you have to think about it. So sensor may be affected temperature. So that's why some sensors incorporate the circuitry to reduce this error. Okay. So directional means what? Care must be taken with the respect to the orientation of the sensor and the magnet. That I am telling you. So if you want the reverse directional, so you have to change the position of the magnet. Means north pole to south pole, south pole to north pole. That position you need to be changed. Okay. Some Hall effect sensors will also be there. Okay, detect the presence of ferromagnetic materials. Okay, or non-magnetic fields. Okay, so sometimes ferromagnetic materials also been used. Okay, so it's also behaves like a magnetic property. You can convert it in a magnetic with the presence of lines of force. The variable reluctance sensor. So that Hall effect sensor also using different applications. Okay, so variable reluctance sensor, that portion I have already been discussed. Okay, so it is also related to the Hall effect sensor, so that is also implemented. Okay, that Hall effect sensor also implemented as a variable reluctance sensors. Okay, in the mode of variable reluctance sensors. Okay, used to measure. So why we are using? Used to measure the speed and or the positions of the moving metallic objects. Okay, so that variable reluctance, how it is possible? So difference of your air gap. Okay, so if that air gap is different, okay, so different length of air gap means what? That area of that flux distribution will be different. Okay, if the flux distribution is different, so rating automatically means values automatically different. Okay, so that's why you can say like that. So variables positions and speed application, you can use this type of sensor, and it is sense the change of magnetic reluctance. Okay, so when it will be able to sense and the changing of the magnetic reluctance. The variable magnetic path is there. Okay, so how is it possible? By changing of that air gap length. Okay, so if that air gap length is different, so magnetic field magnetic reluctance path will be different. Okay, if it is different in magnetic reluctance path, then it reads different value. So it is analogous to electrical resistance. Okay, so you can understand that means change of that magnetic reluctance means it is analogous to electrical resistance. Okay, and near the sensing element, and it is nearer to the sensing element. So an important thing is required to conditioning the circuitry while the useful signal. Okay, example that LM1815 from National Semiconductor. Okay, so that examples are there. Okay, what this type of sensor is there. So it is, you can see the diagram is there for the motion sensor. Okay, so motion sensor means it's related to the variable reluctance sensor. Then how it is work? Okay, so how variable reluctance sensor work? So you can see the magnet in the sensor automatically will be there. That diagrams is there. So variable reluctance sensor constructions. Okay, so construction is there. It is electrical coils and fields. Okay, so electrical coils mean electromagnets. Okay, electromagnet is there. It is your magnets. Okay, that yellow color portion, it is your magnet. So when that electricity passing through this coil, so that ferromagnetic portion will be made behave like a magnet. Okay, so if the magnet is there, so north pole to south pole, maybe north pole to south pole, then magnetic lines distribution always be there. Okay, so it is distributing. So as ferrous objects, okay, as ferrous objects move by the sensor, so magnetic sensor create the magnetic field. So here you can understand it creates the magnetic field as ferrous objects, so ferromagnetic objects moves to the sensor. Okay, that movement is responsible for the sensor. Okay, sensor is there. Okay, resulting the change in the magnetic flux indicate the EMF in pickup coil. So two coils are there. So one is pickup coil. Okay, so pickup coil will pick up that voltage level. So sensor is there. So target gear is there. So magnet is rotating. Okay, so that gear is there. Okay, it is rotating. Okay, if it is rotating means that sensor tip, you will know that electromagnet will be placed in the sensor tip. Okay, then magnetic field line will be distributed like that. If that target gear is rotating, then what happens? Then you can see that due to the rotating of that gear, so part of flux will be there. Okay, and it is your air gap. Okay, air gap, you can observe that air gap is different with that. So grooving is there in your target gear and typical configurations. Okay, so that sensor will measure that value. Okay, that voltage, peak level of voltage in output voltage you can observe over here, peak to peak output voltage. Okay, so that's the basic working principle of your variable reluctance sensor with the presence of your magnetic field. Okay, so now other some diagrams are there. Okay, so typical application safety. Okay, sorry, SAFT of the velocity sensor. Okay, so that is your position sensor and the velocity sensor. Okay, velocity sensor, ABS and the traction control. That I am telling you now. In traction you are using crank. Okay, crank and cams shaft position sensor. Crank type shaft, I am told you that compressor. Okay, so normally in compressor of the traction device, the crank type shaft is there. So shaft normally it is cylindrical path. Okay, smooth cylindrical path, but crank type shaft means it having some rectangular portions in that in that smooth shaft. Okay, that smooth shaft is fine. It is look like some rectangular in shape, but it is a shaft long in but rectangular shape. Lot of 2-3 rectangular shapes are there. So what happens when that shaft is rotating, okay, in the magnetic field, so that rectangular portions is behaves like a piston. Okay, it behaves like a piston. Okay, so some of the piston is connected with your crankshaft, you can say like that. So smooth shaft, okay, in the smooth shaft some of the piston, okay, metallic piston is connected like that. So if it is rotating, so piston also rotating. So what happens, you have to think about your positions. Okay, so normally it is used in your traction. So sensor schematic is there. Okay, you can see the sensor schematic and CV axle. Okay, so install. So that reluctance variables, so shaft are there. Okay, so that groovings is there. Okay, different groovings are there, and it is your on-off sensor. It is your on-off sensor. Okay, on-off sensor is there, and gear. Okay, so that gear is there. Okay, so that difference also be there, and this is shaft positions. Okay, that hackett position is the shaft. Okay, that is sensor. So when it is rotating, so you can see that length, that grooving length is given, and the thickness of that grooving length. So all are given, that measured value are there. So that as per the application, and some schematic diagram is given for your CV axle. Means it is schematic, means block diagramic, pictorial form, and the original diagram. Okay. Then interfacing concern. So interfacing means what happens? So sensor is there, so and sensor is working as per the change of the magnetic field. Maybe different other parameters are there, but interfacing concern means you have to fetch that data. Okay, if it is moving or if it is rotating, so you have to collect that data. So that's why some of the interfacing concept also be there. So who are the responsible for that interfacing concept? So EMF, that developed EMF is proportional to what? That EMF proportional to the rate of change of magnetic flux. So magnetic flux lines are there, and it is cutoff flux is there. So that rate of change of magnetic flux is responsible for EMF development. Okay, so that EMF is proportional to that value. So it dictates the ferrous magnets. Okay, so it dictates the ferrous material. Ferrous material must be moving. That material must be moving for the sensor to generate the signals. Okay, that so to moving for the general signal. Okay, that output voltage. That output voltage is dependent. Okay, that output voltage on dependent the velocity of tooth wheel. Okay, that velocity of the tooth wheel that you can get. The performance may be reduced as slow speed. So different options you can get. So first one, that EMF is proportional to the rate of change of magnetic flux. That is number one. So you can get that generated signal strength. Okay, so if it is required amplification, so you can go for that amplification. So some amplification circuit is required. Okay, after getting that electrical, if it is sufficient, okay, so then you can go, there is no need for any amplification circuit. But in output voltage, definitely that dependent on the velocity of the tooth wheel, means how fast it is moving. That wheel means, you know, that previous case, that wheel, the tooth wheel is there, so it is grooved, no, that's why it is called tooth wheel. Okay, so how fast it is moving, so that due to the depends upon that fastness rotations. Okay, fast rotations, the cutoff flux will be different. Okay, so if it is rotating very fast, the cutoff flux will be, you will get very fast cutoff flux. Okay, that's the concept. Okay, so you will to get it. So perform may be reduced with the slow speed. Okay, so if that fastness is there, so you will get the better value, means high EMF value. Okay, if it is moving in less speed, so you will get the less EMF value. Okay, depending upon your velocity of your tooth wheel. Okay, then the next type of transducer, that is called, it is ultrasonic transducer, means basically based on your sound wave. Okay, so ultrasonic transducers. Okay, so ultrasonic transducers, okay, the piezoelectric transducers, and piezoelectric transducer is device to convert the electrical energy into ultrasound. Okay, so it is convert that electrical energy to the ultrasound. Okay, upon receiving that sound echo, okay, that pressure wave will be there. So that's so you can see it's an example of a piezoelectric sensor. Ultrasound sensor is an example of a piezoelectric sensor. Okay, so you will get that electrical output. The how in piezoelectric effect sensor, what happened, the piezoelectric crystals are there. Okay, so that if you provide some pressure on it, so you will get some electrical output. Okay, so how would you get that electrical output? So due to ultrasound, that if you give some of the ultrasound, okay, so that is reflected. Okay, that is reflected to the any of the reflector, means sound reflector, and coming back to you, and it will providing you some pressure wave. Okay, that pressure wave connect push. Okay, that pressure wave is directly hit to your piezoelectric surface, piezoelectric crystal. And if the pressure wave is coming to the piezoelectric crystal, so definitely the output of the piezoelectric crystal, if there is some pressure is there, so definitely will get some electrical output from that side. Okay, so back from the surface, the ultrasound transducer will turn sound wave into electrical energy. Okay, which can be measured and displayed. Okay, I think you are able to understand that operation. The ultrasound are the sound wave above the normal range of human hearing. Okay, that should be the greater than 20 kHz. It's a common concept. It should not be below 20 Hz. That will be supersonic. Okay, so it depends. So it should not be human range, human hearing range. So 20 Hz to 20 kilohertz. But otherwise, there is a noise. You can it's not that sound will be audible. Okay, so you are eligible to hear the sound. So it will not be better for us. Okay. So how it will be work? You can show that that pulse echo sensors are there. Okay, piezoelectric sensors are there. You are transmit the sound. Okay, so that is transmitting. Okay, transmitting and sensing. Both are there. Pulse echo sensors. Okay, so red one is the transmitting the sound wave. Okay, that is transmitting, and then it is reflecting after coming back to your sensor terminal. Okay, so sensors are there. Transmit and receive sensor, both are there. Transmit and receive. Okay. Since the piezoelectric crystal, okay, since the piezoelectric crystal generates the voltage, okay, when force is applied to it, okay, that same crystal can be used as an ultrasonic generator and the detector. Okay, so I think you are able to understand. So why we are using ultrasonic generator? Okay, that is capable enough to generate that value. Okay, to detect that value. Some systems are separate transmissions. Okay, that is given separate transmission and the receiver. Okay, component. While other combine both signals, the piezoelectric transducer. Okay, transceiver. Alternative methods for creating and detecting the ultrasound include the magnetostriction and capacitive actuations. Okay, so both of the orientations are there. Okay, both of the orientations are there. Okay, so that's the basic motivations. Okay, I think you are able to understand for ultrasound transducer how it is working. Okay, so from this chapter actually you are getting different ideas of transducer, sensor and their operating principle. Okay, so actually these subjects is specially designed, okay, for the lot of ideas about the measurement and instrumentations. Okay, that's why you can develop your idea to go through these subjects. Okay, basically go through these subjects basically in the domain of measurement. Okay, here you know that sound is transmitted through the propagations of the pressure of the air. Okay, speed of the sound of the air normally 331 meter per second at 0 degree and 343 meter per second and 20 degree for the dry air. So digital signal processor, okay, that embedded in the signal sensor calculate the distance between the sensor and the objects that you are studied. Okay, that concept you are already studied in your I think last level physics book. Okay, so how much distance is there? Okay, if echo is there, so how to calculate the distance from the echo to the listener? Okay, that concept is using over here, but who is responsible for this mathematical of the logical calculation? Some of the processor. Okay, that processor will be there inside of your sensor or the transducer module. Okay, that processor will calculate that rest of the portion. So how far that object is it? Okay, how much time is there? Okay, so that can be calculated by the processors. Okay, so here you can see the sensor is there and objects also be there. So providing that sound wave, so it is coming there and it is coming back. Okay, so amplitude here you can see it is around 200 kilohertz, and echo pulse then transmit that pulse and transmit that pulse to time interval is almost 10 millisecond. Okay, so distance it is calculating. So it is operating principle of the sonic distance sensor. How would I using the sonic ultrasonic sensor for find out the distance? Okay, so different mathematical steps are there, that x equal to v sound equal to speed of that sound with the time, where v sound is known as the speed of the sound, t is the time of the flight, so how much time is required, x is the distance between sensor head and the object, and range of the sensor is varies, okay, between the 5 centimeter to 20 meter. Okay, that is given. Okay, the sensor is not appropriate for the very short distance measurement, so otherwise it will not perfectly, so that sound is directly coming to back. Okay, frequency of the response. Okay, that frequency of the response is distance measure update rate. okay, varies with the distance measured, okay, in general about 100 Hz, okay. So normally you are using the piezoelectric crystal, okay, the piezoelectric crystal have the property of the changing size when the voltage is applied, okay. So voltage is applied means, or the pressure is applied over here. So applying alternating current across them cause them to oscillate very high frequency, okay. If you give some alternating signal to that piezoelectric same crystal, so you may cause that it is high frequency oscillation will be there, okay, produce very high frequency sound wave, okay. That sound wave also been developed from this piezoelectric crystal, and when it will be reflect back, that sound wave also catching by this piezoelectric sensor and find out that electricity, no? That means EMF induced over there, EMF generate over there, okay. Ultrasound sensor works on the principle similar to the radar and the sonar. The sonar, you know, I think so. That is in your plus 2 level syllabus. That radar and the sonar evaluate the attributes of the target. Okay, what kinds of target is there? Interpreting the echoes from the radio and the sound wave respectively. Okay, so you are able to calculate the distance by using that ultrasound sensor. Then where it is applications, where it is using in medical applications, you know that now microsurgeries are there with the high frequency sound wave, okay. So medical ultrasound transducer, so ultrasound, you know that ultrasound means sensing, okay, that come in the variety of the difficult shapes and size of the use of the making pictures of the different part of the body. So all of you know about the USG, ultrasound sonography is there now. So different part of the body, if there is some scanning, you can say like that, different USG scanning is there, okay. Different body parts, or find out any stone is in your different body part, like gallbladder, kidney, okay. Different application you can use it, okay. So transducer may be, okay, that may be used for that passed over the surface of the body, okay. So transducer is there over the surface of the body and inserted into the body openings such as rectum, the woman's reproductive organs, okay. The clinicians perform the ultrasound guide procedure to use the probe of the sensing system hold the ultrasound transducer. So that portion, that sound wave and the transducer, both are present on the probe, and that portion you are want to be scanned, okay. That is rubbing of that portion. So what happened? So its sound wave will be there, that will be reflected back and come back to your system. That piezoelectric sensor will be there that can fetch that signal, and they can design and they can draw that approximated diagram over their calculations, okay. So technology can be used. That technology can be also used for wind speed and the directions, okay. Speed through the air and the water, fullness, okay, fullness of the tank, amount of liquid in the tank. Sensor measure the distance of the surface of the fluid. So a lot of applications are there, okay. So other different application is obstacle avoidance. If there is any robotics obstacle avoidance, okay, the infrared, they are sending that is there any obstacle, so it can be stopped, okay. So burglar alarm means that infrared, I am telling you now, that infrared applications, okay. So it is connected in front of your home, okay. If any unwanted person is try to enter to the home, so you will get that alarm, okay. Proximity sensors actually, non-detective testing and etc. So different testing also be there, okay. Then laser ultrasound system, okay. Then we can go for another one, that is called laser ultrasound system. And in case of laser ultrasound system, you can see the diagram, okay. So the diagram is there, okay. So control blocks is there, okay. So laser means it will be pointed out, okay. So different EMAT pump, okay. So different positionings are there, okay. So that electromagnetic acoustic transducer, so special type of transducer is used, that is called EMAT, okay. That it having some control in it, okay. So it will make it laser, okay. Laser beam it will form, okay. And you are going to pulse there, then how much frequency, pulse width. Okay, all our specifications are given. Okay, you can use some laser ultrasound system means pointed out, laser pointed, so that all the values, okay, all the sound will say pointed to the significant areas. Okay, so that you can say like the laser ultrasound system. Different applications also be there. You can see that ultrasound, that values you are given. So what is written? An automated weld inspection system. So when that welding is required, okay, so it is some zoom value. Okay, so zoom value of this portion. Okay, so welding is required, so the sensor will be there. Okay, that laser sensor will be there, ultrasound sensor will be there. If there is any breaking, means any discontinuations are there, okay, so that will be detected by that sensor. Okay, and that will be detected by the sensor, and after getting the detections, okay, that portion will be welded. So it is did for our these kinds of configurations and application. You can see normally different automobile industries. Okay, like if you see that when that cars are developed, okay, so there are different stages. Okay, so most of the stages, okay, different very world famous or world renowned cars, so most of the stages are there, that is totally automated system. Means like your Mercedes, like your Audi, different companies are there, so they are entered the designing, okay, from the very beginning to at the packaging, at the end of that car production, everything, every stages will be done by automated. So how to find out that when that welding is pending? Okay, so everything enter the system, you are going to be scanned. Okay, and it will be painting everything, so equal thickness of that painting. Okay, so combinations of the color, how to select that one, everything will be designed by that automated system. Okay, so so there will be total thing will be done by the robots actually. Okay, robotics, robot automated system is there. So that you can go, that scanning is there. So if there is any kinds of welding is required, so it will be welded like that way. Okay, so that's why it is called automated weld inspection system. Okay, so it's totally based on that electromagnetic acoustic transducer, EMAT. Okay, system consists of the laser beam delivery subsystem, stepper motor delivering linear screw. Okay, so different linear screw, data acquisition card, computer software, and the control unit. So total big drives are there. Okay, so controlling unit also be there, means processing unit. So who will process when it will be on that terminals, means on that switch on, switch off, every when that motor will be turned on, everything will be decided by that control panel. Okay, control switch will be there, and that movement of that any of the instrument, so who will design that movement? So it will be very good movement in like your stepper motor will be there, so very calculative movement. In single word you can say very calculative movement will be there. Okay, so where you can say that generated ultrasound traveling. Okay, generated ultrasound traveling through weld system received by the EMAT. Okay, so for the ultrasound welding you are using, so traveling that ultrasound sensor over your system, and when that welding is required, that will be done by system. So here you can see in indicate laser beams are emitted. Okay, the laser beams are there. So how it will be there? Mirror 1, mirror 3. So that concentrated. So EMAT system is that. This is your EMAT system. The laser will be there. Linear screw, that is screw is there. Then plane mirror 1. So all are that reflected like that. That position will be welded. Okay, beam delivery. Okay, so from here it will be welded. Okay, that zoom portion, I think you can understand. It is the diagram of EMAT. The several identification of the solar beam, deflect of the chip packaging. So packaging cases, packaging industries. Okay, means IC fabrication industry, PCB board fabrication industry. Okay, different industries, that all that processing, that sensor totally depends upon your sensor and transducer and that automated system. Okay, that automated system. Okay, that control everything. Then that's you can say that cross sections. Okay, that bad solder bump. Okay, so where that soldering is required, good solder bump. Okay, it is soldering is good. Then who is scanning? That sensor and transducers. So it is your head below defects. So some defects are there. The damages are there. You can see over the damages. Two medium size voids. near to the interface. Okay, void is there. Okay, soldering is not going to good. Poor wetting and intermediate conditions, that positions. Okay, so different defects are there. Okay, that will be, you can see it's a good soldering, that proper mixing of that combinations. Okay, that we will scan that one for sophisticated device, and from the day one I am telling you na, sophisticated applications. Okay, that will be decided which type of sensor and transducer you are using. Okay, so automated things. So all the kinds you can see defects are there. So that will be only done by your concerned concerned transducers of the sensors. Okay, optical micrographs. Okay, good and bad solders, bump, cross sections. Okay, all the cross sectional areas are there, and inspections are done by that solder bumps and crucial process microelectronics interfaces of the industry. Okay, that you are doing. So it's an intelligent laser. It's an example of intelligent laser ultrasound system. Okay, so how it will be work. Okay, that is given. So different points are there. Laser beam delivery, which is responsible for fiber coupled sensor. So fiber, you are sensing the signal strength. Okay, that carry that position, optical fiber. Okay, DVT, digital voltage and smartness. Smart image sensors. Okay, model, new wave, research polarized, different positions are there, and that segments it is discussed. So autofocus, taper motor. Okay, laser input coupler, which one is vision system. Okay, all are automated system. Okay, examples for the motor controllers, PC control and data acquisitions, manual excitation stage. Okay, fiber optics cable. So all are there. Okay, so different steps are there. If you go through that one, so specifications with their details is given over here. But this all are for your informations. Okay, this is for your informations. Okay, so you can go through it, you can understand. So my agenda to include these kinds of slides and present here, so you can understand that practically where the sensor and transducers are using. Okay, for which systems. Okay, that is our main motivations. Okay. Here you can see that is laser ultrasound inspections, LUI system. Okay, so that enter system is given. I think you are able to understand the diagram. Okay, that automated system. So then photo interruption. In my last class I have started about that photo interruption. Okay, means today I am also discussing about your discussing about where it is going to be used. That means normally that photo isolations. Okay, as an optical isolation. So here you can see that transistors are there, emitter and detector. Okay, isolations are there, emitter and detector. So if there any isolator, photo means if the pulse is given or the signal is given, so optical emission will be there. If any obstacle is there, so that value, that means obstacle is there. So if you can see that total thing will not be coming to here. Okay, some of the obstacles due to the presence of that obstacle. Okay, so exact value is not coming here, so you can say like that there is some obstacle. So where it is used, use emitter and detector. Okay, for the photodiode pair. Okay, so photodiode pairs are there with no obstructions detected. Okay, there is no obstruction due to is high. When an objective blocks and the light is detected is low. Advantages, what are the advantages? Simple to interface, expensive and reliable. Okay, so it is quite cost efficient. Okay, so that's why you are using that type of isolator. Practically how it will be look like that photo interruption type, different types of you can interruptions. Okay, wide variety of the package and the orientation. So as per your company, so their packaging will be different. Okay, and the orientation also will be different. You can see different shapes and size that photo interrupter. Okay, means photodiodes are there. Types is logical. Logic means digital, means plus minus volt, and another one is analog. Okay, so digital as well as analog, both are applicable. Okay, so manufacturers, who are that manufacturing? Fairchild, Honeywell. Okay, different companies are there. Only two names are mentioned over here. Okay, that photo isolator. Then photo interrupt applications means that I am telling you na encoder base. Okay, that encoder base will For angular measurement, that means velocity measurement, position measurement, shaft movement, that I'm telling you na, in that case of Hall effect sensor. So encoders are there, and computer mouse with the balls, that is also encoder. So we are right now digital mouse we are using, so photo beams are there, okay, from that mouse, and if a movement is there, so then the cursor of the mouse will be rotating, okay. So from there you can understand that idea, okay. The movement is the sap movement, that encoder type, that silly cycle is there, and on silly, that means plate, rotating plate is there, that you can see that gaps, okay, that gaps are there. If the rotation is there, that will sense, means a light is coming from that side. If that obstacle is there, okay, so that photo detector, okay, all of the photo detector obstacle is there, so it will face that signal, so you will get the signal. If that detector is not there, means you will not get the signal. So it is again digital form, analog form, both are applicable, okay. So photo interrupt applications, where we are going to be applied, detects of the holes and the slot of the positions of the linear slides, okay. Elevators we are using on it, elevators, okay. Detect on the locations of the product on that assembly lines, okay. So the second options. Then pressure sensors, okay, pressure sensor also be there, okay. So that uses to detect the pressure of the fluid and the gases, okay, fluid or gases, we are going to measure it for the pressure. Different diagrams of pressure sensor, but you know that signals are getting, so we'll all are the example of electronics sensor, okay, electronics, okay. So technologies, what are the strain gauge, piezoresistive microelectronic system, that names that I'm already told you. So application based, okay. So first one I told you some of the specific sensor name and their discussions and their operations, how we are implementing regions, okay. But here we are using that pressure sensor, means which type of sensors are coming. In that case, strain gauge, that is number one, mechanical, that conversion is there, mechanical conversion, so that I have discussed. Then piezoresistive or piezoelectric, you can say like that, that crystals are there. Then main system, micro mechanical systems are there, okay. Each sensor has the pressure range that works, so definitely all the sensor is not working in the single application, so different applications as per the range of pressure, okay. So if you give more pressure in the strain gauge, so it will be damaged, okay. So piezoelectric, so definitely the range of application is given, so most of having some analog output, so most of the having analog output need amplifications. Basically that developed output is very less, means electrical point of view, electrical signal point of view, so you have to amplify it. Amplifier circuit is important. Some have built in the amplifier for the direct connections into the microcontrollers, okay. So some of the microcontrollers are there, they are processing that purpose. Microcontroller is not amplifying, microcontrollers generate the signal, okay, how much amplification is required. So amplifying is done by your amplifying circuit, okay. Different circuits are there, microcontroller gives the signal to the circuit, so how much, means develop the pulse of the circuit, okay, switching pulse of the circuit, so how much amplifications are needed. Then pressure sensor type, what are the defined pressure sensor type? Differential pressures, okay, means difference with two of the developed pressures, so difference between two or more pressure introduced in as input to the sensing unit, okay. Two inputs are there, absolute and the gauge pressure, okay. Absolute and gauge pressure is the pressure relative to the perfect vacuum pressure to set the pressure, like pressure at sea level at one input, okay. Two to one input pressure gauge, okay. So input also input means important, how much input is required. Two pressure differential pressure means two input is required, basically one pressure will be subtract with the another one, but absolute pressure is only one is enough, that's why one input. Then pressure sensor application, where we are applied for it. Pressure sensor, measuring the pressure of the gas and fluid, measure the altitude, means by atmosphere pressure, okay, means altitude, that how far from the sea level, okay, that you can calculate. For plane and or the weather balloons, okay, in balloons you can also measure it. Okay, pressure flow, measure flow. The pressure sensor is conjunction with the venturi effect of the measuring flow. Flow also very important. Measure depth of the water. Okay, when the measuring liquid, most of the sensor are not rated to have that unclean liquid. Okay, basically that water means it's not the clean water. Nah, definitely there is a mixing of different minerals, then waste, okay, oil, lot of things are there. So that's why depth of the water all the time you will get the accurate one. It's not like that, but till you are getting some of the nearer to your actual one. Okay, the liquids that find out that one. So hygrometry is there. So hydrometer you have to use to find out that absolute, sorry, that relative density. Okay, the contact sensor component. Okay, the small amount of air in the tube, right, because the sensor will create the barrier from the liquid. Okay, accelerometer, okay, means how much acceleration is required. So you can see the diagram. Okay, use the measure of the accelerations. Okay, common SI unit meter second to, that is meter per second square, properly the time of that force. Okay, g force, gravitational force, actually g force means gravitational force, the rate of the acceleration when that one g force vertical direction. So 1, 2 and 3 axis configuration with the 3 axis is there, gives the vector of that acceleration in the directions. Okay, you can understand that one. Okay, simultaneous directions. Okay, with the triaxial accelerometer. Okay, accelerometer, you can get the earth gravity 120 g. Okay, that vertical and the horizontal movement. Each sensor has the range of its works, most having the analog output that needs application. Some have built in the amplifier and direct connections of the microcontroller, that you can see from that. Okay, accelerometer, different another examples. Okay, that you are using mechanically, accelerometer behaves like a mass damper spring system, MEMS, that is single, what you can say, like the micro electromechanical MEMS system. Okay, under the influence of the gravity. Okay, acceleration, retardation, proof of mass deflects from the natural and neutral positions. The deflections measured the analogous with the digital manner. Okay, all the codes you are getting, the integrating piezo registers, all are connecting with that one. So internal Faraday shield. Okay, so Faraday shield also be there for making the system unchanged with the external interference. Okay, so so all the different theme of electrical isolations, protections, all are there. Okay. So now accelerometer applications, gyrometer in there na, in your applications, means smartphone. It is also been used. Can be used to sense the orientations of the vibrance of the shocks. Used to electronics like Wi-Fi, iPhone, why iPhone use, then accelerometer integrated once gives the velocity, integrated the second times give the position. So integration process, not the precise, and the introduce error into the velocity positions. So you can be able to measure by using your mobile phone, because that sensor is already integrated with your mobile phone. Then these all are the references. Okay, that what I am following. So that is copper. Okay, WD copper, AD Flix, that is very good books of measurements. Okay, electronics that culture. Okay, different books also been Wikipedia and different internet resources we are using for it. So if you want any kinds of discussions, you can ask me. So if there any discussion, you can ask me any question. So I can discuss it again. Some of the time positions, I mean some of the topic means based on our discussion. Okay. So if you is there, so you can ask me. If you have any doubt, you can ask me, so I can discuss that points. Okay, so I think you don't have any doubt on it, so I can close my session. Okay, so thank you all of you.